All right, the time is here. Let us get this rectangle to bounce on the screen. I'm so excited. I hope you are too. So we're going to make, well, it's a square that's going to bounce. Okay, so let's remember what we were talking about last time, because that's how we're going to program it. And then let's actually make it work. I'm so excited. Okay, so as before, we'll draw those screen boundaries, get them in, and then we're going to make a square in a random location inside of the boundaries. And finally, we will give it a random direction to start. Okay? And then looping forever, because the direction is going to be stored as an offset, right? It's going to be xy, right? X offset, y offset. And that will determine where the turtle is going in space. Okay, we just take the turtle, and after we've, of course, morphed him into a rectangle, we will add the x offset and the y offset to its current xy coordinate, and then that will make him move over here. Okay, that's how a turtle moves. Okay, that's the beauty of it, and yeah, that's the idea. So the direction, again, will be stored as these arrows, a certain offset that will represent a direction. And yeah, every direction has a certain offset. We're going to have to figure out how the turtle hits the walls, and we've talked about that. So maybe we'll use 200 for the walls. And if that's the case, we can just check those things, and suddenly the turtle's within the bounds. Okay? And once we know, like we use an if statement to figure out if the turtle hit a certain wall, then we just change the turtle's direction to get him to bounce in the other one. Okay, so the idea is you negate the x offset if you hit a sidewall, because you were going this way with some x offset, and you were going either up or down with a y offset, and you just need to start going that way on the x-axis. Okay, the y offset can stay the same. Like if you were going up and you hit this wall, well, you can keep going up, but you just need to go up in the opposite x direction. Okay, I hope that makes sense. Please yell at me in office hours or via Piazza if it doesn't. But I want this to also be exciting and to be very clear. Okay, so yeah, it's just a bunch of negation in a sense. Once you get your mind wrapped around the fact that we're going to use just like an offset to represent an arrow, suddenly we can do cool things with that arrow. Okay, so let's make this happen. All right, so I have taken the liberty to open Python, our last project, and a blank file. So let's do all this again. So we're going to draw a rectangle again. That is our bounding rectangle, so I surely better include that. And then this will be our screen. Negative, it starts at negative 200 again, remember? Let me just make a blank slide so that I have some scratch to work with when I explain things. So here is our, oh my, no thank you. So here's our little screen that we're going to draw on. We gave it its upper left corner of negative 200, 200. And so, oh, sorry, that means like here are the axes really. 0, 0 is right in the middle. And so the width of this rectangle was 400 total, because it goes between the negatives and the positives. And the height was also 400. Okay, so now it's our job to put the turtle somewhere within that. All right. So let's get this working. Now, one thing that I do want to do is get the turtle on the corner so we can like maybe expand this rectangle a little bit, because the turtle does take up space and it like goes with the middle. So let's just make this start. This is going to be bouncing square.py, and I'll save it in my documents as usual. And so let's go ahead and run this. And so we've got our normal place to go. Now we have a turtle that we need to transform into a square, right? So we got to change its shape. So we say turtle dot, where did it go? Appearance, shape. Turtle dot shape will say square. Okay, so we'll make the turtle a square, and then we'll see if he's big enough for us. And you give it a string square that will determine whether what kind of thing it is. So now the turtle has been made a square. I don't know, that looks a little small to me. Let's double the turtle size. And remember, the way to do that is to do some stretching. So let's see. I guess we want to do all this stuff here, shape size or turtle size. So I want to stretch the width and the length, maybe by 2. So let's do turtle dot either shape size or turtle size. They're the same thing. 2 times, please, the turtle. And this last one we won't give it. We don't need to. Just be default. Okay, so now we have a reasonably sized rectangle, and I think I want to know how wide it is. Like, is it 20 by 20? Because let's do something. Let's take the turtle's current offset and figure out like how big it is. Or actually, let's play around with these. Like maybe we could make them 210, and I guess that makes it 420. And that puts him in the middle still. Oh, because he's still over there. Never mind. This isn't going to help. We got to move the turtle in somehow. Turtle dot. We need to get his position, because I want him to be within the rectangle this time. For real, for real. Where do we get his coordinates? There we go. Let's get his position. So x, y equals the turtle's current coordinates. So turtle dot pause or position, and let's have the turtle go to like a little bit more to the right, x was 10, y, and a little bit down, minus 10. Let's see if that's within the bounds. Not quite. Let's try 20. Yeah, okay, it was 20. So the turtle is, that means it's a 40 by 40 rectangle, because I moved him 20 by 20 and he was in the middle before. Okay, so the turtle is 40 by 40. Now we know. So that's useful for us, because that means his location should only ever be between, and it's not 200 anymore, like I've been saying over here. It's really a bit smaller than that, because 200, if the turtle's 200, is going to be a little bit past the wall. We don't like that. So let's figure out where the turtle's location should ever be between. Should be between the x values. So negative 200 plus 20, negative 180 to 200 minus 20, which is 180. And same for y. That's beautiful. Okay, so the turtle's actually on the edge when, let's see here, 180. It'll be 180 for us now. Okay, I'll put this in bold just to show you that it's a new thing. Okay, did I say that wrong anywhere else? It's not wrong, it's just a first approximation. Okay, so these are the values that the turtle's location should ever be. Okay, so we can use that now. Let's put the turtle at a random location within the bounding rectangle. Or bouncing. Okay, so we need to give the turtle a random location now. So let's say random x equals something and random y equals something. And we need to make those somethings between negative 180 and 180. Okay, so we know how to do that using the random module now. We can say random.randint in between negative 180 and 180. Okay, did I already import random? I did not, so import random. We'll say random x equals random.randint negative 180, 180. Okay, so we'll copy that. Now we have a random x and the random y, and we'll put the turtle at that location. Dot go to random x, random y. And now we can start playing around. Ooh, so the turtle, we got him moved here. And it's interesting how they moved the turtle. It wasn't like in a... Oh, I did that. Never mind. I guess technically this stuff is no longer necessary. Given the above experiment. Okay, so we gotta make the turtle come up so he doesn't do any of that, and let's give him a color as well. So oh, I'm in random, that's why. Let's give the turtle a fill color. Turtle.fill color, and we'll give it a color. Yeah, violet sounds good to me. I wonder what the difference between Python's violet and purple is. Okay, so turtle. Let's do it up here. And so the color of the turtle is the same as the fill color. Fill color violet. And so now we got the turtle in a random spot within these bounds, and we can keep running this. And the turtle will actually go there, which is nice. And it'll go to a different place every time because it's random. I guess eventually it'll wrap around, but it's random and perfect. Now we need to give the turtle a direction. Okay, so let's keep track of our direction. So direction X and direction Y. So those are going to be offsets, okay? So those are going to be little offsets where they're just a tiny amount in a certain direction to tell us which way the turtle's going. Okay, so let's choose our offsets to be within I don't know. They can be anything. Let's choose them to be random random floating point numbers, in fact. Let's see here. Let's get random dot random. Yeah, there we go. A real value distribution. So one with decimal places. So this one is going to return a random number between 0 and 1. Is that good enough for our purposes? Not quite. So we should have a random number between -1 and 1 for each one. Okay, so how about this? Like, this will be -1. So any of these, add them together, certain random amounts will give us some place in a certain direction. So maybe the first time we choose a random number, like our direction X, it'll be like -0.8. And then our direction Y, we want it to be a random number. Maybe that's like, I don't know, 0.4. And that will cause the turtle's direction to be -8 in the X direction, and then 0.4 in the Y direction. So add them together, we get the turtles flying off that way. Okay, so that's the idea. Let's choose random numbers between -1 and 1, but they will be floating point numbers. Okay, they'll be floats. Say random.uniform. Okay. Dun dun dun. A is less than or equal to B, so we're going to do that one. I think this is good. Yes. Okay, so we've got it now. So these are going to be our directions now, our direction X and our direction Y. That will be random numbers. Okay. Now we just need to animate this turtle. Okay, let's animate the turtle to bounce, or to just move in that direction each time. Okay. Each frame, move the turtle's X coordinate and Y coordinate by the directions amount. That's what we're about to do. So pick a random direction for the square, aka turtle. And now let's forever move the turtle in that direction. So right now, let's just worry about moving the turtle. So while true, forever, do the following. Let's see. Move in the current direction if there's nothing in our way. That's what we're going to do. So the way we do that is, again, we'll just use goto a bunch of times. Okay, so we're going to find a new location for our turtle. Still to do, check if we hit a wall and bounce. So after we've done all that and we have a proper direction, we're going to move in our current direction. Ever so slightly. We're going to offset our current position by direction X and direction Y. So for example, if our current direction, or if our current location was, I don't know, negative 100, 100, like we were somewhere up here, then if we added these in, we'd offset them by those things, plus plus. We would end up with the next location a little bit that way again, of course, so that would be negative 100.8 and 100.4. Okay, I hope that makes sense. So this is the way that we're going to animate. We're just going to move the turtle a little bit every round, every iteration of this while loop. Okay, so we're going to say turtle.goto, and then we're going to have its new x. I think we're going to have to find some variables to store, like where the turtle currently is. We have variables to store the direction, but we should also have the turtle's current location close at hand. So let's call, instead of random x and random y, let's call these like location x and location y. How about that? I think that would help. Because then we always know that the turtle is located about at location x, comma location y. We'll make sure that's true in our program. Okay, so assuming that, now we can pick the new locations just fine. So we'll come back to this. So these are the kinds of decisions that you make when you're programming something. It makes more sense for me to call these location x and location y. All right, so we're going to say that our location, our new location, x, is whatever it was, like it was negative 100, so it's that plus the offset in the x direction, okay? Plus direction x. You see that? We're going to do the same for location y, and that's going to be the new spot where the turtle lives, okay? So we've just offset our x and our y locations. So the turtle's now in this spot. The turtle wants to be in location x, location y. To actually do the animation, to perform the animation, we have to move the turtle. And so each time this while loop takes a little bit to execute, we'll get some animation out of this, because the turtle will change by a little bit. So turtle.goto, go to the location where you're currently located in our code. Okay, so there's a bit of a disconnect now between, it takes a while to wrap your mind around this, but we have location x with a certain number like negative 42 and location y. These are variables in our program. And then we also have the turtle itself. And the turtle has a position. Like we have turtle.pause. Okay? For a second, we want location x and location y to be turtle.pause. For a split second, when we change these things to new things, like negative 42.8 and 112.9. For a split second, these variables are different than the turtle's current position. Okay? Those are different things. The turtle is keeping track of its position in its own little variable somewhere. We need to make these places correspond, location X, location Y, in the turtle's position, by telling the turtle to move. Okay? So it's not just changing these variables. It doesn't actually move the turtle. Okay? We have to actually move the turtle with turtle.goto. That's the idea. I hope that subtle difference makes sense to you. So now, the turtle, we picked a direction, and he's just moving. He's ever so slightly in that direction. Okay? So this turtle is moving very slowly, but it's always going to work. Whee! And so we picked that direction, moving a little bit that way. Very fun. Moving that way. Ooh, that almost hit the corner perfectly. That was fun. So turtle's going to the random spot and picking a random direction. Sometimes it's moving faster than other directions as well, though. So one thing I'm going to do, if you ever take linear algebra, or maybe Calc 3, perhaps, you will learn how to normalize these directions. So secretly, this is something called a vector, and we're going to normalize that direction. And make it a bit faster. So here's how we do it. We need to divide the direction X and the direction Y by a certain amount. So, and that amount is math.square root direction X squared plus direction Y squared. Don't worry about this. We're just going to divide these things by that. So this is the normalization process. I hope I didn't get this backwards. We'll find out. And then I'm going to make the turtle move a bit faster by multiplying these by 5. And let's see if that's fast enough for us. So now, no matter which random numbers we pick, we're going to make the turtle always go a certain speed in a certain direction. That's what this normalization gives us. You do not have to understand this. One day you might. Whee! Oh, did I not import math? I did not. How dare I? So you can see that, like, I'm making mistakes. This is a very, very common thing in programming. It's just you try some things, eventually they'll work. It's very good to talk it through as well. So I'm getting a very good experience trying to teach this. But yeah, suddenly we're having programs that take the entire lecture to go over. Whee! Okay, so that's pretty fast. I don't know if that's too fast. Let's try 3. That's all right. Maybe let's try 2. I'm happy with 2. Let's keep it with 2. And so now the turtle's always going to go with a certain speed regardless of its direction, which is nice. Whee! There it goes. Whee! So it's always got the same speed, and now we actually have to bounce off the wall. Okay, so this is what we still need to do. Check if we hit a wall, and if so, bounce off of it. Let's make this work now. So if we go back to where we were talking about this, we know when we hit a wall, if our x-coordinate, depends on the wall, we know we hit a side wall if our x-coordinate gets too small or too big, okay? And we know we hit a top or bottom wall if our y-coordinate gets too big or too small. So it could go either way. It's here if the x-coordinate got small, here if the x-coordinate got large, here if the y-coordinate got big, here if the y-coordinate got small. Okay, so we need to check all of those cases. All right, and again, it's no longer 200s anymore because the turtle has the turtle's coordinates are based on its center. So we want it to be between negative 180 and positive 180. Okay, so here's how we do it. If we say if x, let's see, let's just do them all differently. That would make it easier on me, I think. So if x is less than or equal to negative 180, and the x is the location x, the location of the turtle, right? If it's less than or equal to negative 180, then we know the turtle hit the left wall, okay? And in that case, we need to bring the turtle back to the left wall, set him equal to negative 180, bring him back on the right side of the wall, because he might have exceeded it, less than or equal to. Bring him back, and then also, if you hit the side wall, you need to negate which coordinate, which offset. You need to negate your x, okay? So we're going to negate the x offset of our direction. All right, so we'll say direction x equals, we can just say negative 1 times direction x. That would work. You could also just say negative direction x, either one. I'll do it this way, it's a bit cleaner. So that is the x offset. And now, one key thing to realize is it's not exclusive to hit one wall and not another, because you could potentially hit the bottom wall and the top, or hit the left wall and the top wall. You see that? You could hit them both at the same time if you got that super special case that they were all waiting for in the office. So that means I cannot use elif here. I cannot use it because these are not exclusive. It's very possible that both will happen. I need to check for both. Okay? So elif will not work. I need a bunch of separate if statements. We have to check for all these cases. Okay, so we're just going to try something completely different. It might also be the case. The stars might align. We hit both walls at the same time. So, else if, or sorry, just otherwise, we could possibly, it's easy to do the other side of the wall. These two definitely can't happen at the same time, but that's okay. If the location x is greater than or equal to 180, well, that means the turtle hit the right wall. Let me just copy and paste all this, actually. Probably easier. So in that case, the turtle hit the right wall. Let's put him back on the correct side of the wall. So it was positive 180 that he exceeded. Put him back there, and then let's negate the x offset of the direction again, because still the negation works. Like the turtle was going this way, we needed to just negate the x offset, and it'll go in the negative x direction. Whereas negating the x offset for this one, we'll put the turtle going in the positive x direction. Negation just does it still, and it works just fine. Okay, it'll just make a negative a positive and a positive a negative. So in these cases, I didn't have to change a thing. Okay, now let's talk about the top and bottom walls. So if location y is greater than, or let's do less than or equal to negative 180, the turtle hit the the turtle hit the bottom wall, because the y coordinate of the turtle got a bit small. We don't like that. Let's bring him back on the correct side of the wall. So that means his location y equals negative 180, because he was trying to go down here, and now we got to bring him back up to where he was. Or he was trying to go down here. We got to bring him right back up, pull him up like in Mario Kart. And okay, then we need to negate the y offset of our direction so that the turtle goes in the opposite y direction. The x offset can stay the same though. Unless it also hit a wall, we would have already have taken care of it at that point. Negate the y offset of our direction. So we'll say direction y equals negative direction y. So whatever it was, make it negated. Okay, so that's the bottom wall. Hopefully that makes sense because the y coordinate is going to be too small. Bring him back and change the offset because he was coming that way. You need to make him go that way, which requires the same x offset. These x offsets don't change. The y offset, however, was going negative. We need to make it go positive. That's the idea. And then finally, the turtle maybe hit the top wall. Oops. I'm going to copy all this. So if the location y is greater than or equal to 180, that means the turtle hit the top wall. We need to bring him back on the top side. So he's flying that way. He got to like over here somewhere. We got to bring him back down inside the confines of our space. And then we need to worry about changing his y offset, bouncing him off the wall. Okay, the y offset of the direction. And these 4 cases, technically you can just make 2 cases to always negate things. You might have to do a bit of fancy methods with resetting the location, but I think 2 if statements would probably work with the correct conditions and the correct settings of things. But 4 makes it a bit easier to check, I think, and easier to explain as I do it. So we have now covered all the cases. So bounce off walls, potentially plural walls, if necessary. So we've covered all the cases. If the turtle hit the left wall, the right wall, the bottom wall, the top wall, and we're not using elif anywhere, or else anywhere. Technically we could use elif for in between these 2 and these 2, if we wanted to, but I'll just keep them all ifs, so we always try every one of these each time. Okay? A bit easier to think about in my mind, slightly inefficient, I guess. And then, once we've reset the location of the turtle and its direction, we can just move in our potentially new direction. By offsetting our current position with our direction, which will have changed. Okay? And the turtle goes to that new position, and if I didn't do anything wrong, I believe we have a bouncing turtle now. Okay, so let's try and run this. Oh, that's fun to watch, right? He bounces in different directions each time. So his y offset's about to be too high, and so we had to negate it. We negated that directional offset, and he's going to go off in a new direction now, based on the old one, of course. Like the y offset's getting too small. We gotta make it positive now. The x offset will stay the same for the bottom wall. The y offset will change, vice versa for the side walls. And now we have a bouncing turtle. Isn't that beautiful? And obviously, if you rerun this program, it'll start in a different direction and hit different spots. Like, okay, now he doesn't have a lot of like y magnitude, but oh man, is he getting close to that corner? Isn't that cool? Yeah, so run it every time. It's different every time, and you can change the speed if you wanted to. In fact, we could even ask the user, hey, what speed do you want this turtle to be at? Like, I don't know, multiplier equals input. How fast do you want this turtle to go? Enter 1 or greater. And so we'll just convert that to a float. And we'll just use that. We'll say multiplier. Why not? I guess technically we could make it even smaller, but 1 is probably a good one. Oh no, what have I done wrong? Oh, sorry. I started with a single quote and ended with a double quote. Can't do that. Gotta pick one or the other. And so now the turtle is in his random spot. The program has stopped waiting for me now. Okay, enter 1 or greater. Let's try 1. Let's make him go slow. And so now he's going to go super slow, bouncing off his walls. And we know what 2 looks like, so let's try a different one than 2. Be like, okay, turtle's in a random spot. we want him to go 5. Speed multiplied by 5. Oh yeah. Oh, that was really close. And then we just play this game all day, right? Speed 10. Woo! That is fun to look at. So now it's up to you as the user. You can do whatever you want, okay? So I think that's all I wanted to show you there. That is a bouncing turtle square. It's beautiful, right? Before we go, because we still have some time left, this is a very fun program, we have a bit of time to talk about some stuff that we're going to do next time. So I want to get us to Pong eventually. But first we need to talk about how to move something with the keyboard. So let's move let's make the turtle a rectangle and move that turtle with the keyboard. Okay? So eventually, this is motivation for Pong. This is Pong. Sorry, we're setting the scene. So. So the idea is we have a turtle, we have a screen again, and we have a turtle. Let's make him over on here on the left, and the turtle is going to be a paddle now. It's going to be a rectangle paddle. That's the first idea. We have to stretch the turtle a whole lot more, like not equally anymore. Like we got to stretch a whole lot in the Y direction to make a paddle. And then, if we want the turtle to move based on our input, we have to somehow get keyboard input. Okay, so. And I won't repeat that, but there's a way to use keyboard input to maneuver our turtle. And that brings us now to the turtle documentation again. I think it's going to be here. If it's not, I'm going to have to go and find it. It's probably in some weird spot. So we have click events. Yeah, we have key press events. Yes. So, I think, yeah, on key is probably what we want. Yeah, that's the one. So I think we need to talk about potentially the screen, but we'll get there. We'll get there. We'll try turtle.onKey. So let's see if this works. Otherwise, there's a different way. So let's get ourselves started. Let's like copy a whole bunch of stuff from here to make our screen turtle the size of a square. Let's make him a paddle this time. And so we're gonna make this is gonna be like moving rectangle.py. So let's make the turtle a paddle by changing his shape size to be stretched in the width. Yes, sure, that's fine. 2 is fine, but stretched in the length, I think, is the y-axis. We'll find out. It's either that or the other. Let's stretch that one by 5 and see where we get with that. Okay, that's a bit too much. Let's keep this 1 then. Let's try that. There's a paddle. That looks kind of paddly. I don't know, 1.57 maybe. These are just magic numbers that we'll figure out. That looks like an okay size paddle to me, maybe. I don't know, let's try 6. Oops. I'm happy with this. Let's stick with that. And of course it's in a weird spot right now. We'll deal with that later. But now we want the turtle to move when we press a key. Particularly the up arrow and the down arrow. Oops. And the way that you do that is you say drum roll please, let me find that function again. It's going to be on key, or on key press is probably the same thing. Yeah, so let's do it as turtle.onKey. It takes a function and a key. So this is the one cool thing about Python. Oh no. No, I just want to... Okay. There we go. So functions in Python can take other functions as parameters. Or sorry, as arguments / parameters. Either way. Okay? That's insane. So the first argument to this .onKey function is going to be another function. Isn't that cool? So let's make a go up function. Okay? All right, let's start with a go down function. Def go down. We'll just run it and it'll make the turtle go down. Make the turtle go down by a certain offset. Let's make the offset, I don't know, 10 maybe. So we'll say turtle, we'll get its current position. So get the current position of the turtle. And then we'll offset the y. We'll say, we do need to say turtle.up. That's for sure. We'll say go to wherever it was with its x, and then y minus the offset. That's the idea. And so technically, we should be able to say go down like 3 times, and then the paddle will have moved a little bit. Let's test that. Yeah, so it looked like it moved a little bit. That sounds good to me. And the idea is we can make this go down function run every time a key is pressed. So in the last couple seconds, let's get that to work. Turtle.onKey. We want to run go down, so we'll give that as a parameter whenever you press the down key. Okay, so we'll use the string to represent the key. It seems to like that. And I think this is going to work. Otherwise, we need to include screens, which I might have to talk about next time. So if anything, it's waiting for me. I'm pressing the down key, and darn, it is not working. All right, never mind. I made a way to do it without using screens. We just have to call another secret function that is called turtle.listen. And so this is just tell the turtle to listen for key presses. Okay, and then I also changed onKey to be onKey press because we want the turtle to move like immediately because we're playing a game. We want it to move when the key is pressed down. This other one on key would have worked when the key is released, like you've pressed it down and now you're taking your finger back up and the key has been released. So no, we want it to work on when it's first pressed. When we press the down arrow key, the turtle goes down. Okay, and so then we just tell the turtle to please listen for all of the key presses now. He wasn't doing that otherwise, and now that he's listening, it'll work. All right, so now I'm going to press the down arrow, and each time I do it, I can even hold it in, the turtle moves. And I don't have the up arrow working yet, so he's going to go off the screen. But that is enough for next time, I think. So we'll use onKey, press. We'll use onKey press to make the fun get called when we press a certain key. All right, make the function that we care about to get called. Okay, and that's the idea. And then the only last thing we need to worry about is to say turtle.listen. So start listening to the keyboard. That's the idea. Okay, so that's how we're going to make Pong. We're going to move our paddle using this on key press stuff. And that is a good place to stop, I think. So with that, I will see you next time.